So hey guys, thanks for watching again. This week we're going to be looking at graphics. How to implement them, how to code them up, how to display elements relative to each other, how to display data from the game. We're going to be focusing at the COM screen, but the principles are the same for any data that we want to display. Next video we're going to be focusing on the interaction, the touchscreen, the encoders, the buttons on the encoders. If you want to be the first to be notified when the rest of the series comes online, don't forget to hit the little subscribe button. I want to thank all the patrons that make this content possible. They had early access to the Bits and Droids Fly32 library, and it is a library for specifically aimed at the ESP32. Now, why do we need a special library? That's because the ESP32 does some things slightly different. In the old one, there were some serial functions that aren't available on ESP32 and it couldn't compile or upload. Now, this library also comes with a neat feature. At first, we had to do serial.println connector.send com1 swap or something like that. Right now, I've shortened it to connector.send and the command. You don't have to do the serial.println yourself, the connector will handle the rest. Now, before we can start coding, or we're going to take a look on how the screen actually works, we need to make sure that we've downloaded the tft_espi library. You can either do that through the GitHub page or directly from the IDE. Now, once we've installed this, you go to your Arduino folder. There is a folder called libraries, and in there there's another folder called tft_espi. Now, there's a file in there that's called user_setup. So let's open this. It doesn't really matter what editor you use, just as you're able to make some alterations to the text file. Now, the first thing that we encounter are these dashes and lots of defines, etc. This file lets us customize the library to whatever kind of chip we're using. Not every TFT screen uses the same chip. A very popular one is the ILI9341 or the 46888, etc. I have another one that's called the ST7796. Check where you've bought the screen to determine which driver you're using. For me, it's the ST7796. So mine was like this. Make sure that you uncomment the line of the one you're using, and that if there's another one uncommented, that you comment that one. So only your chip is highlighted. There is a part by default that's not commented out. I believe it's the ESP8266 that they've not commented out by default. So they think that if you're using that board, those are the settings. If you encounter anything that's not commented out, please prefix a little two backslashes in front so it doesn't look at that part of the code. Now, if you reach the ESP32 dev board section, you guessed it, we are using the ESP32. This is the section we need. We can uncomment the defines of the pins that we are using. So the MISO, MOSI, SCLK, chip select, DC, and reset. Now, if you followed along with the previous video, these pins are already set up perfectly for us. So if you want to follow along with the coding video and you haven't seen the last one, check in the description down below. Now, the define touch CS also needs to be uncommented to make sure that we can use the touch functionalities of our TFT screen. That's all done. Don't forget to hit the save button for whatever program you're using, or Ctrl S, and close it down. What your screen that you're watching me on and this one have in common is they both have pixels. Now, that may sound very logical to you and you'll be like, Dave, that's child's play. Everybody knows that. That's perhaps true. I don't know. Not going to judge if you don't. But why is it important? Well, it's the fundamental on how the screen works, the LCD technology behind it, and what we're going to be using to manipulate what is being shown on the screen. Now, the pixels are at the foundation of our approach. If you want to draw something in the upper left corner, it's the first pixel in the first row. If you want to do something in the far right corner, it's the maximum amount of pixels down, maximum amount of pixels right. And with that logic, we can display almost anything on here. Well, almost anything, depending on how many pixels you have. It's difficult to draw round shapes or something, so it depends on the screen you are using. By controlling each pixel individually, we're able to display almost anything on the screen like this. Or the screen you're watching this on, for example, it just tells the computer or the microcontroller, this pixel needs to be this color, it needs to be this hue, saturation, or whatever it uses, and display that. Now, these pixels can't turn off until you cut the power of the entire device or the entire screen. Something like an OLED screen can also individually turn on or turn off each pixel. Now, because this is a cheap TFT LCD screen, that is not the case. So it's always going to be on, just what it displays will be different. Now let's have a quick look on what we are dealing with here. Once we power the screen up, the pixels are illuminated. Now we've got 400 pixels in the width and 320 pixels in the height. Now these pixels are divided in rows and columns, so the best way to work with them would be some kind of grid system. Now, because with many pixels, these grids can be really small. On a computer, we don't really have some round shapes available. Now, we might see round shapes, but depending on how many pixels you've got available, depends on how round a circle will appear. If you zoom in far enough, we will always see that you get a kind of jagged edge. Now, if we take a small little TFT screen of 8 by 8 pixels, it's very hard to portray a round shape, and you will always see that it's kind of square. Now, the more pixels we add to this circle, the more clearer it will become that we want to see something round. Now we're going to focus on the grid system. We have an x-axis and a y-axis. X is going to be the horizontal one and the y is going to be the vertical one. Each pixel is represented by a column and each row of pixels is represented by an I vector. Now, the further we go to the right, the higher we go up until the max amount of pixels our screen has. Ours has 480, and the lower we get, the higher the y value goes. Now, this might sound counterintuitive, like the higher the y is, the higher the value, but that's because the way that our screen works is that it has the portrait mode as default. The moment we flip it, the y is going to run downwards. With a grid system, we can also perform some simple math. Let's say that we have a width of 480. If we want to get the exact middle point of our screen, we can just do 480 pixels divided by 2 is 240 pixels, and the same goes for the height, which is going to be 320 pixels divided by 2 is 160. So if we want to draw something on the middle of the screen, we want to draw something at 240 and 160. So I was editing this video and I already hit the 1 hour mark and I still had lots and lots to tell you. So I'm going to do it slightly different. In this video, I want to do a little summarized version of the techniques used in coding, structs that we'll be using, how we use them, how we can use functions, how we can make it modular. And later this week, I will just release the full step-by-step guide that will take over an hour for those of you that still have questions. Or if you don't want to wait for that, there's already a written article that goes into every line that I've used, every technique that I've used, for every shape on the screen. Now, this isn't even all of it, but this gives you a kind of an impression on how big the sketch is going to be. And I'm going to save you guys some time by just highlighting the key parts. Now, the one thing that no matter what shape you want to draw, we need 3 libraries, the spa.h, the tft_espi.h, which will drive our TFT screen, and the Bits and Droids Flight 32. The Bits and Droids Flight 32 is just a custom-made library to really fit the ESP32 and lets me fine-tune it for this board later on without affecting the Arduino board too much or the other way around. Now, for both of these instances, we need to create an object so we can initiate it, draw shapes, or get the data from the game itself. Now, a place that really gives you lots of information is usually the GitHub page of the library you want to use. So in this case, the tft_espi library. If you go to the header file, so tft.espi.h, you'll find all the functions that are available to the library most of the time. So here you find all the resources you need to draw all kinds of shapes, from pixels to lines to rectangles. It's good to note that we've got 2 types of rectangles. We have the draw rect, which will just draw a rectangle on a screen. So if you want to create some kind of frame, we could create one rectangle and then one little bit smaller in the middle and a little bit smaller, then we get a frame. Or we could make it more easily just draw 2 shapes by creating a large square that's filled in and an overlapping shape that's the same color as the background to create a frame effect. Now it will make our screen work a little bit harder because it needs to fill the entire rectangle instead of just drawing the frame, but it's much more easier to code up. Now, if we take a look at the library, we have a fill rect function, which takes an x coordinate starting point, a y coordinate starting point, like we saw how our pixel works, a width, a height, and a color. Now let's give you first a quick background on how these colors work, because they're not your usual 888-bit colors, so 24. We're going to be using 16-bit colors. Now the colors that we are used to, or you even perhaps worked with when you create a little website or whatever, are RGB 888 usually. So 8 bits for red, 8 bits for green, and 8 bits for blue. Now, the more bits the higher the value of the red, the more green, the more blue. And this way you can mix up any color you actually want. Now we have, I keep saying this, but it's quite a cheap screen. So it can't handle the 888 color scheme. What we're going to be using is 565. 5 bits red, 6-bit green, 5 bits blue. And that's because the green has a certain, more of an impact on the color results. This will lead that we have less colors to work with, but it's also easier to handle for a component like this. Now, why do I show you that on this website? It's because it's a color picker and we need hexadecimal values. Now you could do some kind of calculation to determine what the hexadecimal value is of a 565 RGB layout, but I'd suggest to just go with the color picker. Yeah, you can just hover around. Perhaps you don't want a black background, you want, I don't know, light gray, which is normally 167, 167, 167. But in hexadecimal, it's 0x Bravo 596. Where the 888 really shines is the consistency. So B0, B0, B0. So just as we saw here, 176, 176, 176. Because we used the 565, it's a little bit more of a complex formula, Bravo 596, which is a lot harder to calculate from the top of our heads. Now let's start with the rectangles, because there are many rectangles that we want to draw. We want to draw the outer frame, we want to draw the background in the middle of the frame. So we're gonna be using that function a lot. So what did I say? Fill rectangle. Yeah, it's a fill rectangle. So a rectangle which is filled with a solid color. X, Y, width, height, and color. Now, if we go to our sketch, we want it to be modular. So for every shape, I've created a separate struct and a function to draw it. Now, what is a struct? Let's say struct square. It's going to be a little container that holds several variables for us. So here I did x start, so the x starting point that we're going to be using, the y starting point. We are going to be using width, a height, and I've mentioned already a 16-bit int, so int 16 underscore t color. Now this is just to determine that it's always going to be a 16-bit int, so it has a different range of minimum and maximum. Now, but what is so great about a struct? Well, we've got this little container that's called square. So if you now want to create a square variable, we can say square gray square is, and then we just open these parentheses. And we can say whatever we want, 10, width of 50, I don't know, and a height of 50 as well. And with the color TFT underscore black. If you go into the TFT ESPI library header file, you find some predefined colors already in there that you can use just as TFT black, TFT white, silver, and a whole lot more. Now I made a little mistake because here we need the closing signs. You might think, okay, we've done some double work here. We created a square struct, then we created a square object. But what this lets us do is you can access one of these variables by calling its name. So we can say gray square dot x start, and it will return the 10 that we defined here. If you do the y start, it will return 10. If you do the width 50 dot color, it returns TFT black. It won't return the text, but the variable it represents. So this gives us a nice approach to really make it modular, and we can maintain our squares in a single place. Because if we want to edit the gray square, we don't have to go looking where we draw the square. We can just look for, here is it, and on another place we draw it. So if we want to make it bigger, we add a 0 here, and on the place where we draw it, it will just draw it bigger. So an example like I did with the drawing of squares is I created a void function. I wanted to draw something. I don't want to return something. So void draw rect. Let's call it draw fill rect, because then we know that it will always be a filled, because you also have to draw a rectangle in the library as well. Yeah, and it will just be confusing. So let's take something that isn't in the library as a name, and that still makes sense to you on what it does. So what does it? It does tft dot fill rectangle. Now what it normally takes is the x coordinate, y coordinate, width, height, and color. Well, the same goes for here, but we want to have a parameter that's called square, so a square struct, so one of these. Let's give it a name to draw. So the square that we want to draw, if we pass that to this rectangle, we will draw that square. So we can say to draw dot x start to draw dot y start, etc., till we have all the variables. And here we go. So we now have a single place to draw fill rect that we can just pass a square and it will draw it on the screen. So in our setup block, we could already do draw fill rect. Now what would we want to draw? The gray square. I hope that makes sense. So in a really quick recap to show you how this works, the struct is a container. It holds variables with a name, so x start, y start, width, height, and color. If we create a new square struct variable, we set these values to whatever we want, 10, 50, 500, 50, TFT black. We could also do some math in here, so 50 plus 50. If you want to position elements relative to each other, we can do the math in here as well. So now it will become 100 high. We then have created a struct variable, but we want to draw it. So we created a function, draw fill rect, that takes one of these structs as a parameter. So we call the function, pass our defined struct, and it will draw everything for us. Now, if you just have one rectangle, this might not really be efficient because, why not just do it tft.fillRect and pass the variables here? But let's say we have another variable in a square, which we do have, is yada 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 yada. We can then just do draw fill rectangle in a square. And once again, we only have to look here on which variables we're going to be using, what we want to change, and we don't have to look in our code or dig through heaps of code to alter anything. Now, depending on what kind of shapes you're going to be using, I've created a struct for every shape I've used. Rounded corner, which is in the TFT library as tft.draw fill rounded rect. So it gives rounded corners. Triangles, you can use it for circles, lines, whatever. I've created a struct, and if I wanted to create a shape, I created a variable from that struct type, and then I've drawn the rectangle with a function or the square with a function, triangle, and in my block where I want to draw it, I've created just call that function and pass it those struct variables. So it's a little bit more complex than we usually do, but it's also, in my opinion, a bit clearer to read. Now, another thing that I've done is we want to change modes. We have a radio screen. Later on, we will be adding more screens. We could create just an int that says int mode is 0, and then if int mode 1 is, we're going to be calling that radio, int mode 3 is going to be the GPS, whatever. That works, but it's really hard to tell what 0 is or 1, 2, 3. So then we could leave a hint. 0 is radio, 1 is GPS, whatever. It makes it clear if you look up here. Or we could use an enum. Now, an enum lets us type a name for a variable which represents a value. Now, because we didn't assign a value here, radio is going to be 0. See, even I have to look something. I just had a full brain thought. I couldn't remember, but apparently an enum starts with 0. So our enum here has value 0, 1, 2. So it's the same as our mode. So we could do mode is 2, mode is 3, and it would be the same as if we say mode is GPS. It would be the same as mode is 3, or mode is 2, or mode is fuel. But this gives us a much clearer look on what the mode actually does. So we can say right now we start with the mode is radio. I'm not quite sure. Just to be very clear, I'm going to put it down here because then we have already created the enum. Oh, and if we call the value, we know that it exists. So now we can say mode is radio. It makes it much clearer to see what kind of mode we're in without having to use some kind of cryptic int. Now we could also, if you don't want to use 0, 1, and 2, or 1, 2, 3, you could also do this 1, 10, 100, and 1000. Now the value radio represents the value 1. If you call fuel, it will be the same as calling 10. If you call GPS, it will be the same as 1000. Now, in the loop block, I've created a kind of construction where I said switch mode. And this lets us do case radio, do something, execute a radio mode. It lets us do case GPS, do something, execute GPS mode, and case fuel, I don't know. Let's just do something else. This way we can clearly see if we have the radio as mode set, do something. If you have the GPS set, do something. If you have the fuel set, do this. Now with this approach, it's also, here I did it in the setup block, right? The draw fill rect. But it makes more sense because we don't want to draw the radio interface on the GPS screen, to create separate functions for each screen. And then I have an initialize radio, where I initialize stuff like this, draw the rectangles, draw the shapes that we need, enter the base text in the buttons, etc. And we have radio mode function. So what I've done is in the loop, if it says case radio, radio mode, here we go. And don't forget the breaks in each case. Now, if my mode is at radio, I want to do radio mode. And in the radio mode, I want to, if I haven't drawn the radio yet, so if not drawn radio, initialize radio. And then drawn radio is true. So if we create a boolean, drawn radio is false. There you go. So the first time we enter the radio mode, so if we, at first at top here we said int mode is radio, so it will be radio mode when we start it up. It will see, okay, radio mode activated. If not drawn radio, so if it hasn't drawn anything on the screen yet, draw these rectangles, because we only want to draw them once. We don't want to redraw every button. We don't want to redraw the trim. We want to redraw that once on there, and the values in there, like the frequencies and whatever, those can be dynamic. So these will be going into the radio mode. So here we will, it's not the right formula, but display 123.850, and this will change 730. Very special, doesn't matter. This will update during the course of the game, right? We up our radio, we switch radio frequencies, these things change, so this goes in radio mode. In the initialize radio, I put everything that doesn't change. The trim, it's there. The swap button, You can press it, but the graphic looks the same. If you want to change that, you can do that as well, but for me, it doesn't make sense. What else do we want in there? Initializing the buttons, initializing the placeholder text. That all goes into the initialize radio function. And the things that we want to change or update go into the radio mode function. Later on, we can add more. So initialize fuel, initialize, I don't know, GPS, and then we have a GPS mode, radio mode, which do exactly the same thing. So another thing that might perhaps seems daunting is the buttons, the 10 buttons for the A to C menu. Now, I've got a struct for the rounded square. I've got an array that holds 10 buttons of the type rounded square, so these. And if we create an array of structs, it's important to add parentheses, parentheses, 0 if we don't want to fill it yet. This makes sure that it gets filled with rounded square structs with every value set to 0. We have to set it at something before we run the code, or else there's a chance that you access wrong memory in there that isn't there. Get all kinds of strange behavior. I don't think it will even let you upload the code. Now I also created an array of the text, and I'm gonna let younger Dave explain why we go with a loop function to draw each of the 10 buttons, because there is a logic to it. We could create 10 separate buttons in here, rounded square, button 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, get a really long list of codes. While we could just use some math to calculate certain positions, the starting position, the width, the height. So we could create 10 individual buttons. Button 1, which is going to be placed here. Button 2 is going to be placed there, etc. But they are evenly spread out in a grid-like layout. So it makes more sense to find how each button relates to each other, to create some kind of formula that places them for you. Now we've got 10 buttons. There is something about these buttons, and that's the color is the same, the size is the same, the height and the width. And because we want them in a kind of a grid layout, so a row and columns, there is also some kind of mathematical logic to it. The columns all start at the same x position, and the next column starts at the same x position, and the rows all start at the same y position for the row, and the lower row a higher y position. Now with this knowledge, we can use a loop to draw each 10 buttons for us. The first time we run the loop, it's width times 0, so this will be 0. Margins times 0, so this will be 0 as well. So we just have the x margin as starting point. The next time this will be 1, so we add the width of the button, so it moves to the right, then it would hug the button. Then we add a little margin times the amount of buttons that we have, and make sure that we create some breathing room besides each button. Now we're going to be adding the top button at I, but the bottom button is going to be added at I plus 5, or 0 plus 5, so 0 and 5, 1 and 6, 2 and 7, 3 and 8, 4 and 9. Because each element in the array consists of the same kind of struct, so rounded square struct, it has the same variables, only a different value, but they all have the radius, width, height, starting point, etc. So if we divide the size of one of these elements by the total size, we get the amount of elements that are in the array. I hope that makes sense. So we have an array of 10. Let's say each element in there is 10 big. So the total array will then be 100. If we do 100 divided by 10, so the size of the elements, we'll get 10 elements in the array as well. So it's kind of a way to dynamically check how big the array of structs is by using an element and the size of the total. Now I haven't explained everything in full detail, but by applying the same principles, I'm convinced that you can fill in all the gaps. For the topics where you're still struggling with, or where you're like, oh, I'm quite interested how he did that, go check out the article. Everything's in there, from mathematical equations to placing objects relative to each other. and the full 1.5 hour documentary on how each line is coded up will be releasing as well. If you made it this far, thank you very much, and if you haven't already, hit the little like or the subscribe button. It really helps the channel out. I want to especially thank all my Patreon supporters who make this video possible, and I put the link in the description if you're interested in that as well. Next week I hope to release a new update for the connector and the library as well, where I streamlined some things, got rid of a lot of boilerplate code in the library, and hopefully make some things easier, add some rudder curves, etc. So check it out. So as always, thank you. We've surpassed the 1000 subscriber mark, so amazing guys. Thanks for the support, and I hope to see you all in the next one.